This video is about graphing logarithmic functions. We're looking at the parent equations y equals the log of x, or y equals the natural log of x, or y equals the log base 2 of x. If we were putting that in the calculator, we would have to put that in as log of x divided by log of 2. Because remember, the calculator cannot do bases other than natural log and common logs of base 10. Now this particular graph, remember, as an inverse of the exponential function, they do reflect over the line y equals x, but this particular graph is going to look similar to this. This graph is going to pass through the line 1, 0. So that is its x-intercept. It does not have a y-intercept. It has an asymptote that is a vertical line, and that asymptote is x equals 0. As we talk about shifts, if we have horizontal shifts, that's going to change where the asymptote is. It's going to change where your x-intercept is. If we have vertical shifts, it's going to change where this value moves up and down on the graph, but it won't change where the asymptote is. Vertical shifts would not change the asymptote, only horizontal shifts. We do have reflections. If it just reflects, it wouldn't change the position of the asymptote. Again, it would have to be a horizontal shift to change that. We can still have vertical stretches and shrinks. We can have horizontal stretches and shrinks, but they, again, would have some impact on different parts of the graph. As we look at the domain of our basic parent graph, the domain, you'll see, starts from this point over. So that means that it would be greater than 0, but going to positive infinity. The range in this case is from negative infinity to positive infinity. It is up and down the entire y-axis. So we have all of this information about our parent graph. And again, that does change depending on the shifts of our particular graph. If we look at the transformations that can occur with a log graph, we have y equals a times the log of b times x minus h plus k. Again, we have those extra values just like we did with our other functions. So we have the value of a is going to provide a stretch or a shrink. And that is going to be a vertical stretch or shrink. Also, the sign of a is going to reflect us over the x-axis. Then we have the b value inside, and that is going to give us a stretch or a shrink horizontally. And remember that horizontal amount is opposite what you think it might be. So a value bigger than 1 is actually a shrink. A value between 0 and 1 is actually going to stretch it. The sign of b is going to reflect it over the y-axis. The value of h is going to give us horizontal shifts, Again, that's going to be opposite the sign. So positive is going to shift us left, negative is going to shift us right. The value of k is going to give us vertical shifts. And it will be the same as the sign. A positive is going to shift us up, a negative is going to shift us down. So again, once we understand the shifts with any function, these are basically the same regardless of what that function is. So let's look at this example. Y equals the log of x minus 3. If we predict what's going to happen in this particular graph, it is going to shift this graph to the right 3 units. So if we drew that particular graph, and normally it would go through that point 1, 0. So a shift 3 units is going to make that point become 4, 0 for that x-intercept. It's going to shift the asymptote to the right 3 units. So that asymptote has moved over to, I'm sorry, I drew it too far over, 3 units, not 4 units. So the asymptote is going to be at x equals 3. And our graph is going to resemble that. So again, we have some other situations where we have y equals the log of x minus 3. That prediction would be to shift down 3 units. That would not change the position of our asymptote. It would still be at x equals 0. It does change our value from being 0, 1 to being, from being 1, 0 to being 1, negative 3. Because it has shifted that graph down. As we look at the equation, y equals the log of x plus 1 minus 4. If we were to make the prediction of that graph, that would shift to the left 1 unit, and it would shift down 4 units. This particular graph, y equals the negative natural log of x minus 2. That particular graph would give us a shift to the right 2 units, and then it would reflect over the x-axis because of this negative. With this right shift, it does shift the asymptote also, so our asymptote would shift also to x equals 2. So these are things that we should be able to pick out from looking at our equations and talk about in terms of graphing our logarithmic equations. So similar to our other functions, we just want to apply those same principles to our new logarithmic function.